So section 3.12, we are going to work on the systems of linear equations. We're going to deal with two equations and find the solution for x and y. Let's start with the example 3.12.1. You are given two differential equations in terms of x and y there in the dt. We briefly talk about in the d notation in chapter 1 and chapter 2. So actually we're going to use d notation in here. We're going to say d over dt as a d. Then I can rewrite the first equation as dx plus dy plus 2y equals to 0. And then second equation is going to be dx minus 3x minus 2y equals to 0. And solve these two differential equation, meaning we need to find x equals to something, y equals to something, and those expression should be in terms of t. So just like systems of linear equations in the regular x, y, and z, we want to do the substitution here. I'm going to say dx equals 3x plus 2y. So moving 3x and 2y to the other side, and then you're going to substitute in here. If we do, we have a 3x plus 2y plus dy plus 2y equals to 0. This is not good. When you do substitution, we try to eliminate one variable. In here, looking at x and y. So this is not a good way to do it. So what we want to do, make sure you want to change to one variable. So we want to make this equation dx minus 3x equals 2y. So what I did, isolate one variable to the other side. So the left-hand side is x term, right-hand side is y term. I have a y equals 1 over 2 dx minus 3 over 2 x. Then we have a first equation as this. We can substitute 2y here, and we need to have a dy. So we're going to take the derivative from here. We're going to have a dy equals 1 over 2 d squared x minus 3 over 2 dx. Now we can substitute dy here.
We have a dx plus dy is what? 1 over 2 d squared x minus 3 over 2 dx plus 2y equals to what? Dx minus 3x, and right-hand side equals to 0 now.
Now, by looking at this equation, everything is in terms of x. That's what we want. Now, we're going to multiply everywhere times 2 first so that we can get rid of this fraction.
Then we have a d squared x, and then we have a 2 dx here. It's going to be negative 3 dx here. There's a 2 dx here. That's going to be plus dx and minus 6x equals to 0, because we need to multiply 2 to negative 3x.
Then once you get to here, it's going to be section 3.3. It's a homogeneous equation. Now the ox equation from here is going to be m squared plus m minus 6 equals to 0. We have m plus 3, m minus 2 equals to 0. So we have a positive m, and m equals to negative 3, m equals to 2. This is for the x terms. So x equals c1 e to the negative 3 as 3t plus c2 e to the positive 2t. And then we need to find y. Y equals 1 over 2 dx minus 3 over 2 x. Therefore, y equals 1 over 2 dx, derivative of dx. So negative 3c1 e to the negative 3t plus 2c2 e to the 2t minus 3 over 2x. That is c1 e to the negative 3t plus c2 e to the positive 2t. From here, negative 3 over 2 c1 e to the negative 3t plus c2 e to the 2t minus 3 over 2 c1 e to the negative 3t minus 3 over 2 c2 e to the positive 2t. Now we need to collect the like terms. So e to the negative 3t together. That's the negative 3c1 e to the negative 3t minus 1 over 2 c2 e to the positive 2t. Let's do this. We need to isolate a variable. So first, we're going to write this in terms of d. So we have a dx equals 4x plus 7y. And here, dy equals x minus 2y. From the first equation, we have a x, and y. Dx minus 4x equals to 7y. The second equation, we have y, x, and y can have dy plus 2y equals to x. Unlike the previous problem, either one will work because the first equation, left-hand side, x and x, right-hand side, 7y. So y equals 1 over 7 dx, 4 over 7 x. The second equation, x equals to y and y. We're good to go. So for this problem, I want to show you what happened to pick one versus the other. So we'll do both. So let's start with the first choice, dx minus 4y equals to 7y. From there, we have a y equals 1 over 7 dx minus 4 over 7x, and dy will be 1 over 7 d squared x minus 4 over 7 dx. Use these two equations and substitute it into second equation. Then we have dy 1 over 7 d squared x minus 4 over 7 dx plus 2 times y 1 over 7 dx minus 4 over 7x.
So let's collect the like terms. Square terms, we have 1 over 7 d squared x. dx terms, the 2 over 7 dx and minus 4 over 7, going to be negative 2 over 7 dx. And then x terms, negative 8 over 7 x from here, and then minus x. So 7 over 7, that's going to be negative 15 over 7x equals to 0. So if you multiply 7 for everywhere, we have a d squared x minus 2dx minus 15x equals to 0. Ox equation, m squared minus 2m minus 15 equals to 0. m minus 5, m plus 3 equals to 0. m equals to 5, m equals negative 3.
So now we worked on x terms. So the x equals c1 e to the 5x plus c2 e to the negative 3x. We have y equals 1 over 7 dx minus 4 over 7x. Use that. Y equals 1 over 7 dx minus 4x. So that is 1 over 7 dx 5c1 e to the 5x minus 3c2 e to the negative 3x minus 4x c1 e to the 5x plus c2 e to the negative 3x. Then y equals 1 over 7, and c1 is 5c1 minus 4c1, which is c1 e to the 5. T, sorry, has to be all t, minus 3c2 minus 4c2, that's a 7c2 e to the negative 3t. So these are the solution, y here and x here. Let's do this again. Instead of choosing y equals 1 over 7 dx minus 4 over 7x, you select x equals to dy plus 2y equals to x. And then we're going to substitute this guy to the left side. Then we have an x here. So now we need a dx. That is d squared y plus 2 dy. And these two, put it into here. Then dx is d squared y plus 2 dy minus 4x dy plus 2y equals 7y. I want you to copy this down as well so that you can compare two different approaches. And the answer at the end is not going to be the same.
d squared y, and then dy term, we have a plus 2. Here's a minus 4, so minus 2 dy, negative 8y minus 7y, so minus 15y equals to 0. And from here, we have m squared minus 2m minus 15 equals to 0. m minus 5, m plus 3 equals to 0. m equals to 5, m is negative 3. this is y. So we're going to say y equals c1 e to the 5t plus c2 e to the negative 3t.
So now we have a y. Where's the x? X, we said x equals dy plus 2y.
And then x equals to dy 5c1 e to the 5t minus 3c2 e to the negative 3t. That's the dy plus 2 times y c1 e to the 5t plus c2 e to the negative 3t. Then x equals c1 terms 7c1 e to the 5t and c2 terms negative 3 plus 2, so minus c2 e to the negative 3t.
So it depends on which side you start working on. We end up getting a bit different answers, and they both correct. Let's do one more. From the first equation, we can isolate y. That's the only option. We cannot say dx equals to something. That means we don't have the x information. We don't want to take the integral. So only option from the first equation, we have dx minus 1 equals to 4y. 1 over 4 dx minus 1 over 4 equals to y. And then you take the derivative and put it into here. From the right equation, we can do dy minus 2 equals to negative x. So x equals 2 minus dy, and then put it into the first equation. I'm going to start with the first one. Then we have a dy equals 1 over 4 d squared x. Derivative of negative 1 over 4 becomes 0, right? So we're going to use this to the left-hand side. Dy, we say 1 over 4 d squared x plus x minus 2 equals to 0. Then we have a d squared plus 4x minus 8 equals 0. This is wrong. Why? From here, if we want to put it into ox equation, 1 over 4 m squared plus, there's no prime, so that's 1. Now, what are you going to use this negative 2? We cannot do that. So we need to keep it in the right-hand side. We cannot bring the constant to the left-hand side. If you bring the constant to the left-hand side, there's no way we can do ox equation for just constant. So this one, we need to use the ox equation, this as where yp, and this is going to be yc. So for yc, we have 1 over 4 m squared plus 1 equals to 0. Now we can multiply 4, then m squared plus 4 equals to 0. M equals to plus minus J2. So we were working on the X term. So the X equals, there's no alpha, C1 cosine 2T plus C2 sine 2T. That's the X of C. And then X of P, that's just a constant. So we're going to let that equal to A. And then left-hand side, we have a double prime. So we need to have xp prime equals to 0, xp double prime equals to 0. X double prime is going to go away, and A equals to 2. Therefore, the x equals xc plus xp, xc c1 cosine 2t plus c2 sine 2t plus xp is just 2. So now we need to get the y. So y equals 1 over 4 dx, 4 dx. So if we differentiate this x, we're going to have negative c1 sine 2t times prime of 2t, which is 2, plus c2 cosine 2t times 2, and then prime of 2 goes to 0. We have a 1 over 4 negative 2c1 sine 2t plus 2c2 cosine 2t minus 1 over 4. So that's it. We can write one more time. Negative 1 over 2c1 sine 2t plus 1 over 2c2 cosine 2t minus 1 over 4. That's y, and this is x.